All right, today we're going to talk about a brand new framework for AI agents that could totally change how we use our computers. And it's all based on this one surprisingly simple idea. Let's dive in.
So let's just start with this question right here. I want you to forget about typing prompts into a chatbot for a second. What if an AI could literally just grab the mouse, use the keyboard, and, I don't know, book your flights, edit your documents, or manage your spreadsheets just by looking at the screen? Well, that's the ultimate goal of this new class of AI.
They're called computer use agents. You can think of them as digital co-pilots. Now, the key here is they don't need any special APIs or weird back-end access. They see what you and I see, the graphical user interface, the GUI, and they interact with it. But as you can imagine, building an AI that can actually do this reliably, it's been incredibly difficult.
So why is it so hard, right? Why can't we just hook up a big language model to a mouse and just let it run wild? Well, it turns out the digital world is just full of these little traps that cause these agents to fail over and over again.
Okay, so here are the three main reasons they get stuck. First, they just fumble their clicks. They might be aiming for a button but miss by just a few pixels, or they really struggle to select the exact right piece of text. Second, they get lost during long tasks. I mean, think about a 20-step process like downloading a file, editing it, then emailing it. That's a lot of context, and these agents can just lose track of the goal. And finally, you've got cognitive overload. You're basically asking one single AI model to be a master planner, a visual expert, and a text whiz all at the same time. It's too much.
So the old way of doing this relied on what's called a monolithic model. One big brain trying to do everything. But a new approach is popping up, and it's all about creating a team of specialists. So instead of one jack-of-all-trades, you have different super-focused models that are experts at specific things, with a manager delegating tasks out to them.
And this brings us to the star of today's explainer, a new framework called Agent S2. It is designed from the ground up to solve these problems by really leaning into this new, modular, team-based approach.
And, the inspiration for this is actually pretty amazing. The creators of Agent S2, they looked at the human brain. It's not just one big blob of intelligence, right? We have specialized areas for language, for vision, for motor control, and they all work together seamlessly. So the thinking was, why not build an AI agent the exact same way? So Agent S2 introduces two key breakthroughs. First is what they call proactive planning. So instead of just reacting when it makes a mistake, it reevaluates its plan after every single step it takes. And second, and this is the really crucial part, it has a team of experts with different digital senses. They call this concept mixture of grounding. So let's meet the team. You've got the visual expert. This one's a pro at looking at a screenshot and finding the exact pixel coordinates for a button or an icon. Then you have the textual expert, which uses optical character recognition to perfectly select a specific word or sentence, no more fumbling. And finally, there's the structural expert. This one is a spreadsheet wizard, able to understand and modify cells and tables. Together, they handle all the low-level details, which frees up the main AI to focus on the big picture.
Okay, so that's the theory, right? A smarter planner and a team of specialists. But does it actually work? Well, the researchers put it to the test, and the results, they're pretty impressive.
And the answer is a big yes on this really tough benchmark called OS World, which has complex tasks that are up to 50 steps long. Agent S2 got a 34.5% success rate. Now, that might not sound super high, but it is a new state-of-the-art, beating the previous best models from some of the major AI labs out there.
Let's actually see how this plays out in a real scenario. So the user gives a simple instruction. I think the last paragraph is redundant. Add a strike-through. Now, a monolithic agent might really struggle to select that text precisely.
But Agent S2 knows exactly what to do. It delegates the job to its textual grounding expert, which uses its OCR skill to identify the exact start and end of that paragraph. And the result? A perfect selection and a successful strike-through. I mean, this just perfectly shows the power of having the right specialist for the right job. And here's the head-to-head comparison on that 50-step OS World benchmark. You can see Agent S2 clearly outperforming previous state-of-the-art models, like OpenAI's computer use agent. It just goes to show that this modular framework isn't just some clever idea. It actually delivers better performance on these really long, complex tasks.
But this is where the story gets even more interesting, because the modular design of Agent S2 unlocks this powerful new idea. It's not just about making one agent better anymore. It's about what happens when you start to scale them.
So the logical next question is kind of obvious, right? If having a team of internal experts makes one agent better, what happens if you have a team of entire agents all trying to solve the same problem at the same time? Well, this leads to a new framework called Behavior Best of N, or BBON. Now, the concept is really simple, but it's incredibly powerful. You have multiple AI agents, let's say 10 of them, all try to do the same task at once. They each come up with a different solution, a different path. Then, a separate, impartial judge AI looks at all 10 attempts and just picks the single best one. It's basically like a competition to find the most elegant solution.
And the results are just staggering. By applying this BBON scaling method to agents like S2, the success rate on that OS World benchmark skyrockets from 34.5% all the way up to 69.9%. That's more than double the performance, just by having agents work in a team and picking the best results.
This chart really puts it all into perspective. On the left, you've got that state-of-the-art performance for a single agent. Then, in the middle, you see this massive leap you get by scaling with a team of agents. But look at the bar on the right. That's human performance. At 72%, we are suddenly getting incredibly close to human-level reliability for these complex computer tasks.
And this leaves us with a massive question. We're moving from having a single kind of clumsy AI assistant to deploying teams of competing agents that are approaching human performance. So as these teams become more and more common, which of the complex digital tasks that we all do every single day are going to become completely and truly automated?